Hi, this is Kevin Buzzard from the Xena project, and today I'm going to show you how to prove this basic logical proposition in the Lean theorem prover. So we have three true-false statements, P, Q and R, and our goal is to prove that P or Q implies R if and only if P implies R and Q implies R. And we're going to prove this in Lean's tactic mode, so let's enter tactic mode with a begin end. Let's put a sorry there, and now we see down the bottom here, before we get going, let's just check. We have no errors and we have one warning, and the one warning is because we've cheated. We've used sorry to prove the theorem. So let's remove the sorry and get going. We have to prove an if and only if statement. We have to prove that X implies Y and Y implies X. So that's really two statements. The way to make progress with an if and only if statement is to use the split tactic. And now you can see instead of one goal, we have two goals. We have to prove the left-hand side implies the right-hand side, and the right-hand side implies the left-hand side. So best Lean practice is to put some parentheses, and so now we just have to prove each of the goals individually. Here's the first goal here. We have to prove that something implies something else, so let's assume the left-hand side, intro H, our hypothesis H. So now we have the assumption that P or Q implies R, and we've got to prove P implies R and Q implies R. So our goal is currently an AND, so again we can make progress with the split tactic. There, so now you see again we've got two goals. So let's put them in parentheses again, and what have we got to do here? We've got to prove that P implies R. So let's assume that P is true, and now we have to prove that R is true. Well, P or Q implies R, and we know that P or Q implies R is true, and so we're trying to prove R. We can apply this H then, apply our assumption H, and we're reduced to proving that P or Q is true. But now we know that P is true, and so to prove P or Q we can use the left tactic, which will make progress on an OR goal. The left tactic there reduces the goal to proving P, and we've got a proof of P already, so assumption should prove this goal. There. And now what's happening here, this should just be the same. We're now trying to prove that Q implies R, so let's assume that Q is true. We've got to prove R, but we know that something implies R, so let's use that. And now we've got to prove that P or Q is true, and to make progress with this OR goal we're going to use the right tactic this time. And now we've got to prove that Q is true, but that's an assumption, and so indeed that goal is now closed. So now the other way, we've got to prove that P implies R and Q implies R implies something else, so let's assume that again. Let's assume our assumption P implies R and Q implies R. So now we have an assumption which is an and we can make progress here using the cases tactic. Case is H with, what should we call them? HPQ, no, HPR and HQR would be good names for them, wouldn't it? There. So now we have two assumptions, that P implies R and Q implies R, and we have to prove that P or Q implies R. So again, this is an implication, so we can make progress with the intro tactic, intro HPQ, and now we've got to prove R. So I guess HPQ is an OR. We know that P or Q is true, so now we have to split into two cases, either the case that P is true or the case that Q is true. So we can do cases HPQ with HPHQ, and now again we have two goals, so let's get this right. There. And the first goal, we have an assumption that P is true and we're trying to prove R. Well, we know that P implies R, so why don't we apply the fact that P implies R? And now we've got to prove that P is true, but P is an assumption. So that should do it. And now down here, we know that R is, we're trying to prove R, we know that Q is true, and we know that Q implies R, so we can apply HQR. And now we've got to prove that Q is true, but we know that Q is true, that's an assumption. And that is the end of the proof. We can see it's the end of the proof because if we look down here, there are no warnings and there are no errors. There are no problems with this script, which means that our theorem is proved. So that's how to prove it in tactic mode, and now I'll show you how to prove it in term mode. So Lean's term mode is a bit more intimidating for beginners, but I mean there are advantages. So we have to prove an if and only if, and in term mode the constructor for an if and only if, I guess, looks like this. There, these slightly strange brackets that you get with by typing. You type that, backslash, and then a normal less than, this slightly funny less than. And now you can see now we have two errors, And the error is the fact that we have these underscores, which are things that we have to prove and we haven't proved yet. So our first error is that we haven't proved this. We haven't proved that P or Q implies R, implies P implies R, and Q implies R. So in tactic mode, we use an intro to make progress, but because we're in term mode, we'll use a lambda, because a lambda is term mode intro. So now we've got our assumption H, P or Q implies R. We've got to prove that P implies R and Q implies R. So again, we can use this. We can use this constructor here, and now we've got 3 goals in total, which is 3 errors. And the first one is that P implies R. So let's assume that P is true, and we've got to prove R. Well, H says that something implies R, so we'll do H of something, and now we know P, and we've got to prove P or Q. I guess I can put a $sign here to save me having to use brackets. And I need to prove P or Q from P, and so I guess I can use, I'm going to use the left introduction rule. That will be or dot in L of, and that should be P, yes, HP. And similarly, the same story will be true here. Let's assume HQ, and now I've got to prove R, so that's H of what? The goal is now P or Q, and I know Q, so I need the right introduction rule for OR applied to HQ, so it's going to be OR dot in R HQ. And now our final goal here, again we've got some assumptions. What are we going to assume? We're assuming an AND, so we can do lambda, we can do this, can't we? HPR, HQR. Now what? So now we've got to prove that P or Q implies R. So this is another input to our function. We can just put an HPQ here. Now we've got to prove R. But I guess we need to do a case split on HPQ. P or Q is true, but we don't know which one. So we could do HPQ.elim there. So now we have 2 goals. Our first is P implies R, which is an assumption. It's HPR. And our second one is Q implies R, which is also an assumption. Lovely. And there is the end of the proof in term mode. And as you can see, no warnings and no errors. So we now have 2 proofs of this assertion, one in tactic mode and one in term mode. And as you can see, there are advantages and disadvantages of both approaches. The advantage of tactic mode is we can click around wherever we like. We can see the state of Lean's brain at any point in the argument in tactic mode. In term mode, we can't do that clicking. So it doesn't work. But of course, the advantage of term mode is, I mean, it's only 1 line long, of course.